For about a decade, we had been using the same core topology in our CPUs, the ring architecture. In each generation, we add more cores, more memory, and I/O. If we don't increase the bandwidth of the interconnect between the core, the cache, memory, and I/O, then the interconnect becomes a bottleneck, limiting system efficiency and increasing latencies. That's why, for this generation, we are excited to introduce the industry's first Intel Mesh architecture. It provides a more direct path for data to travel than the prior ring architecture, and many more pathways to eliminate bottlenecks. For example, in the previous design, if a core needed to communicate with a last-level cache on the opposite sides of the socket, the data had to propagate around the ring, through the buffer, limited by 32 bytes of data per cycle, and around the second ring to get to its final destination. In the new design, the data simply cuts across one of the 5 available paths, shortening the distance traveled. But we all know that CPUs don't process one cache line at a time. A real data center CPU will have all cores accessing all caches, all memory and I/O at the same time. While the ring worked well for the amount of cores that existed in previous generations, in this generation it was imperative that we architected the Intel Scalable processor with more pathways to support all of the new resources in the most efficient and balanced way possible, because that's what data center workloads require.